morning and welcome back. Let us see the answers and solutions to yesterday's homework. First question, you are given a vector P. Vector P is given to be 1 by root 2 cos theta I plus 1 by root 2 sin theta j. This is the given vector. What is the unit vector in the direction of vector P? इस वेक्टर की डायरेक्शन में हमको यूनिट वेक्टर फाइंड करना है. If you remember the concept of unit vector, vector P will be U into P, isn't it? Any vector can be written as unit vector in the direction of it multiplied by magnitude of that vector. So unit vector will be vector P upon P. Now vector P is given. This P, magnitude of vector P, we'll find out. How we'll find out? Magnitude will be under root ax square plus ay square. यहाँ पर दो ही components हैं. ax मतलब क्या? I का coefficient, the coefficient of I, that is 1 by root 2 cos theta. This is ax, and this is ay. The coefficient of j is ay. So under root ax square मतलब इसका square, cos square theta, cos theta का square, cos square theta upon root 2 का square 2 plus this one ay square sin square theta upon 2. Is it right? Cos square theta upon 2 plus sin square theta upon 2. So P is equal to under root cos square theta plus sin square theta upon 2. And what is cos square theta plus sin square theta? 1. So this is equal to under root 1 by 2. So the magnitude of vector P is root 1 by 2. Therefore, U will be equal to vector P, that is 1 by root 2 cos theta I plus 1 by root 2 sin theta j. This is vector P upon magnitude 1 by root 2. Correct? 1 by root 2 upon 1 by root 2. 1. So unit vector will be, ये हो गया 1 cos theta I plus, same here, 1 by root 2 divided by 1 by root 2, that is 1. So plus sin theta j. So the unit vector will be cos theta I plus sin theta j. Check into the options. Cos theta I plus sin theta j, that is option B. If I, j, k represent unit vectors along x, y and z axis respectively, we know this, I, j, k are unit vectors along x axis, y axis and z axis. Then the angle between the vectors I plus j plus k, first vector is I plus j plus k and second vector is I plus j. You have to find the angle between these two vectors. इन दोनों vectors के बीच का angle find करना है. So we call this vector suppose vector A. We call this vector suppose vector B. So you have to find the angle between vector A and vector B. Right? To find the angle between two vectors, we can use dot product. Dot product of two vectors, if you remember, A dot B is equal to AB cos theta. You can use cross product also. You can use dot product. Generally, we use dot product. A dot B is equal to AB cos theta. This is the dot product of two vectors. We have to find the angle between the two vectors. So cos theta will be equal to A dot B upon AB. We have to find theta. So cos theta is A dot B upon AB. मतलब हमको फाइंड करना है A dot B. इन दोनों का डॉट प्रोडक्ट, मैग्नीट्यूड ऑफ ए एंड मैग्नीट्यूड ऑफ बी, करेक्ट? डॉट प्रोडक्ट ऑफ ए एंड बी, मैग्नीट्यूड ऑफ ए एंड मैग्नीट्यूड ऑफ बी, ये फाइंड करेंगे तो cos थीटा मिलेगा और cos थीटा से थीटा मिलेगा. So first of all, let us see what is A dot B equal to. A dot B is AX BX plus AY BY plus AZ BZ. So this will be equal to AX BX, means 1 into 1, that is 1, plus AY BY, right? 1 into 1, plus AZ BZ is 0. So it is 1 plus 1 plus 0, that is 2. So A dot B is equal to 2. You got one value. A dot B is equal to 2. Then magnitude of A will be under root AX square plus AY square plus AZ square. 1 square is 1, plus 1 square is 1, plus 1 square is 1, that is under root 3. And magnitude of vector B will be under root AX square, 1 square, plus AY square, that is equal to root 2. Therefore, cos theta is equal to A dot B, 2 upon A B. So that is equal to 2 upon under root 6. Correct? Or if you check the options, इस फॉर्म में वहां पर आंसर नहीं है, तो फिर हम क्या कर सकते हैं? रूट 2 इंटू रूट 2 कितना होता है? रूट 2 इंटू रूट 2 इज 2. सो रूट 2 1 जा, रूट 2 जा. So cos theta will be equal to root 2 by root 3. So theta will be equal to cos inverse of root 2 by root 3. But this option is not there. Cos inverse 1 by root 3 है वहां पर, हमारा आ रहा है root 2 by root 3. So this is not your answer. So the answer must be in sine form. Sine के फॉर्म में चाहिए. So sin square theta होता है 1 minus cos square theta. Sin square theta plus cos square theta is equal to 1. So sin square theta is 1 minus cos square theta. That is 1 minus cos theta is root 2 by root 3. So cos square theta will be 2 by 3. इसका square, that is equal to 3 minus 2, that is 1 by 3. So sin square theta is equal to 1 by 3. So sin theta is equal to 1 by root 3. Sin theta is 1 by root 3, means theta is sine inverse of 1 by root 3. Check the options now. Sine inverse of 1 by root 3, that is option D. So there were only 2 questions in yesterday's homework. Let us move on to the next question today. 3 vectors A, B and C satisfy the relation A dot B is equal to 0. A dot C is also equal to 0. The vector A is parallel to वेक्टर ए किसको पैरेलल होगा? A dot B is equal to 0. Characteristics of dot product. If 2 vectors are perpendicular to each other, their dot product is 0. So A dot B is 0. This implies that vector A is perpendicular to vector B, right? A dot C is also equal to 0, means vector A is perpendicular to vector C. So vector A is perpendicular to both B and C. It cannot be parallel to B or parallel to C. Vector A is perpendicular to both the vectors B and C. Now check the options. B, C, not correct. B cross C, B dot C. Okay. Vector A is perpendicular to B and vector A is perpendicular to C. Means B and C are parallel to each other, right? Or they are in the same plane, either parallel to each other or they are in the same plane. So vector B and C are in the same plane. तो वेक्टर B और वेक्टर C ये दोनों एक प्लेन में हैं. इस प्लेन को परपेंडिकुलर है वेक्टर A. तो इस प्लेन को परपेंडिकुलर क्या होता है? इन दोनों का क्रॉस प्रोडक्ट. मीन्स वेक्टर A is parallel to the cross product of B and C. So check the options now. It is option C. A is parallel to the cross product of B and C. B cross C. So the answer is C. The work done by a force is defined by W is equal to F dot S. W is equal to F dot S. We already know this. It is found that the work done is zero. The work done is zero even if F and S are not equal to zero. So neither F is zero nor S is zero, but W is zero. How it can happen? W is Fs cos theta. Okay, F is not zero, S is not zero, means cos theta is zero. Which angle has cos 0? 90 degree, means theta is equal to 90 degree. It means that force and displacement are perpendicular to each other. Now check the options. So F and S are acting at right angles. That is option C. What is the projection of vector A on y-axis? Vector A is given to be 3i plus 4j, and we have to find its projection on y-axis. So for vector A, x component is 3 and z component is 4, but there is no y component, means its projection on y-axis is 0. There is no y component, means the projection of this vector on y-axis is 0. Check the options. It is option C. Two vectors A and B are given. Vector A is given to be 2i plus 3j and vector B is given to be I plus j. What is the component of A along vector B? A का component B की direction में. Remember the characteristics. A dot B is AB cos theta. What is B cos theta? Component of B in the direction of A. What is A cos theta? Component of A in the direction of B. We have to find component of A in the direction of B, means you have to find A cos theta. So A cos theta is equal to A dot B upon B. So component of A in the direction of B, A cos theta, is A dot B upon B. A and B are known. So A dot B is AX BX plus AY BY plus AZ BZ. AX BX, 2 into 1, 2, plus AY BY, 3 into 1, 3, upon magnitude of vector B under root 1 square is 1 plus 1 square is again 1, that is 5 upon root 2. So component of A along B is 5 upon root 2. Check the options. It is option B, 5 upon root 2. To be very honest, I'm not expecting answers from you. What I want is you should think, you should try to solve it. अपना दिमाग लगाओ. That's only expectations. Answers, solutions, I will give you. What you have to do is just try. अभी आप बहुत छोटे हो, इतने जल्दी एक्सपर्ट नहीं बन सकते. So keep on trying. So we shall stop over here. Rest of the things, rest of the questions, we shall see in the next lecture. Have a nice time. Good day. Bye bye.